So students, welcome back to this channel where we try to make mathematics a bit more fun. And today we are going to be continuing not our ITS series. Today actually I am thinking about making a video about differentiability and what was it again? I think it was called continuity and differentiability. I forgot the name of that. And as far as I remember, I have already made a video on this. Continuity and differentiability. Pardon me if I'm getting another space wrong. Differentiability. I think this should be the one. Okay. Today we are going to be focusing. First of all, this chapter is going to be very easy and very short. In the previous video, I have discussed about when is it that a function is continuous, when is it that a function is not continuous, and how to basically check if limits exist or not. I mean, even though that was thought in 11th standard, but I think uh, going through it once thing for once more time, it's not going to be that bad. Anyway, today we're going to be focusing on a few questions, few important questions. But before that, I want to talk about some important formulas, important identities, which are going to come in handy during this chapter. I would definitely recommend you guys noting these down. These are going to be really useful. First one is limit of x tends to 0 of sine x over x. Now, first of all, the value of this expression would be 1. Why you ask? Because x is very close to 0 and sine of something very close to 0. We can basically write it down like it's a very small number. If it was absolute 0, then sine of x would have been 0, but since it's very close to 0, value of x is very close to 0, so value of sine x would also be very close to 0. And again, say that when limit of x tends to 0, sine of x equals x. So sine of x on the numerator becomes x, and in the denominator we have x, so x over x becomes 1. So this is why how limit of x tends to 0 of sine of x over x becomes 1. Okay, these are very close approximate, I mean, assumptions. I've told you guys, like I don't know how many times before this, but mathematics is a very, think about it, mathematics is a very vague topic, and a lot of things are good assumptions, good approximations. Not there are a lot of things which are not, something that would 100% satisfy, our logical minds. Okay, and then, see this. The value of this expression, limit of x tends to 0 of sin x over x, it's not actually 1. It's something more like, it's more like, hold on a second, let me just refill my pen. I should have done it before starting the shooting of the video. Pardon me for that. Okay, sorry about this. Sorry about this hindrance. The value of limit x as extent approaches 0 of sin x over x is actually something like 0.999999, and these nines and go up to infinite number of digits of the decimal. Okay, that can basically be written as 1. We are saying that 0.99999 dotted is 1. So this is how this value becomes 1. Okay. Now next, let's talk about the next identity. This one says limit of x approaches 0 of tan x over x. This can be rewritten as limit of x approaches 0 of sin x over cos x over x. Now, as x approaches 0, cos x becomes 1 because you know that cos 0 is 1. So, obviously, limit of x tends to 0 of cos x would also be 1. So, this becomes sin of x over 1 over x, and that just becomes sin of x over x, and we know that sin of x over x is just 1 from our previous videos, from the previous identity itself. So it becomes limit of x tends to 0 of tan x over x becomes 1. Okay. Now let's talk about the next one. We just have a handful of them right now. Uh, I mean, you can think of about this as well, like some identities like limit of x tends to 0 of sin x equals x, limit of x tends to 0 of cos x is 1. You can think of these their own identities as well. A few more we got here. This one says limit of x approaches 0 this, of e to the x minus 1 of x. This becomes 1. And you might ask that why does this become 1? Because e to the 0 is 1. Anything to the 0 is 1. And on the numerator we just have e to the x minus 1 and on the denominator we have just x. So calculating the value of this would not be that difficult. We can use the hospital rule in which we would differentiate both the numerator and the denominator. So this can be rewritten as limit of x tends to 0, e to the x becomes e to the x, 1 just becomes 0, and we have as limit of x tends to 0 of e to the x. You can basically write in 0 for this x because know that as something approaches 0 or something approaches a specific number, we can basically say that it becomes that number because the value is gonna be almost the same. Limit of x tends to 0 of x equals 0. Okay. So this is why we can rewrite this as e to the 0, and anything to the 0 is 1. So this expression becomes 1 like that. Now let's do this one, which says limit of x tends to 0 of e to the x minus 1 over x. This the value of this is natural log of a. If you don't know what this means, then it basically means I would definitely recommend you guys watching my videos about calculus and this logarithmic functions. ln basically means a logarithmic function with the base of e. Okay, log a with the base e. You can write this as ln of a, and this is pronounced as natural log of a. Okay, now this can be derived easily as well. I have taught about like, uh, derivatives of exponential functions in my previous calculus videos. I would 100% recommend you guys watching those. So let's do that. We are again gonna be applying the L'Hopital rule. You guys should have learned about it already in the 11th standard. But you know what? Let me go through it for one more time. L'Hopital rule says that when you encounter a situation like that, when you know just plugging in the value as it is for x would give us 0 in the numerator, in the denominator, like 1 over 0. Obviously cannot do that because anything over 0 is undefined. So what we'll have to do is we have to differentiate both the numerator and the denominator. Obviously individually you cannot differentiate the whole thing together, then things would be different. We'll have to differentiate both the numerator and the denominator individually, and then what we get from that we'll have to plug in the value that we are approaching over there. So differentiating this would give us ln of a minus 1, sorry, I'm sorry, it would be minus 0, which can be just be written as ln of a, and in the denominator we would have 1, so this would just become ln of a. This is how this becomes a to the this expression becomes ln of a. If you guys are wondering how the hell this derivative get us ln of a, I would once again recommend you guys watching my videos on this. I have made uh, I would say reasonably good videos about these topics, like why on earth just the derivative of anything, any constant to a variable, and taking the derivative with respect to that variable gives us natural log of that constant. I definitely recommend you guys watching those videos of mine. Okay, another identity we have here, and this one says limit of x tends to 0 of log 1 plus x over x. Now again, we are going to be differentiating here. Uh, this would, on the numerator, we're going to have is 1 over differentiating both the numerator and the denominator would give us 1 over x plus 1 over 1, that is just 1 over uh, x plus 1. Actually, limit of this, the limit of 1 over x plus 1 over x, limit of x tends to 1, which is just limit of x tends to 1 of, sorry, x tends to 0 of 1 over x plus 1. Now plugging in 0 for x would give us 1 over 0 plus 1, that is 1 over 1, that is just 1. So this one as well becomes 1. We have one more important I need to talk about today. It is actually just the the number of the power rule of derivatives. The first rule of derivatives that I learned. So it says that as limit of x approaches 0, of x to the n minus a to the n over x minus a. This becomes nx to the nx to the n minus 1. I'm not going into this proof again because this is just the basic first rule of derivatives that we can learn. If you have any doubts regarding what is going on here, you can definitely. I'm actually if you definitely check out my old videos about calculus and derivatives, all that stuff. So now this was all the important identities that we had. Now let's use them in solving some questions. Actually, I'm only gonna solve one important question today. Tomorrow I'll come back with a few more interesting questions. Today, first of all, let's find this out. We're going to ask to evaluate this as limit of x equals 0 of sine 5x over x square plus 2x. First of all, let's evaluate this. Yeah, actually, was this a question? Asked, first of all, we have given a function. We have been given a function. This is if this function is sine 5x over x square plus 2x when, sorry for that, when x does not equal to 0 and this function becomes k plus half when x equals 0. Now we have been also told that this function is continuous at x equals 0. Find the value of k. Okay, so let's do this. I'm gonna erase the question right here. First of all, limit of x tends to 0 of fx. What would this become? This would become limit of x tends to 0 of sine 5x over x square plus 2x, because here we are approaching a value close to 0. We are not actually getting to the point 0. That means this is not equal to 0. Here x does not equal to 0. That means we will have to use this form, because we have been told that when x does not equal 0, this function becomes sine 5x over x square plus 2x. Okay, so now obviously if we just plug in 0 for x, what we get nowhere, this would become undefined. We have to solve this, basically realize this in a way where plugging in 0 for x doesn't get us to an undefined point. How can I do that? We can definitely use the hospital rule here, where we will be taking the derivatives of both the numerator and the denominator, but there is another way of doing this as well. I think doing it by hospital rule is kind of very simple. Let me do it in another way. This can be rewritten as sine of 5x over x times 1 over x plus 2. Okay, now this can be rewritten as 5 times limit of x tends to 0 of sine of 5x over 5x times 1 over x plus 2. Now, if you guys are wondering what just happened here, uh, multiplying these two would give us sine of x over x times x plus 2. X times x plus 2 would become x square plus 2x, which is the same thing as this. And why multiply 5 here? Because I wanted something over here that looks like as limit of something, let's say s approaches 0 of sine of s over this. When I know that this becomes 0. Now the reason I multiply 5 here, because this way I will get something like this thing would become sine of 5x over 5x. Now when x becomes 0, of course 5 over 5x also becomes 0. So this would become 1. Uh, 5 times. And you guys are wondering, I multiplied 5 in outside the limit and divided the whole thing by 5, that is inside of the limit. I don't think there is any confusion. There should be any confusion regarding that, because limit of x tends to n of a x a times x is the same as a times limit of x tends to n of x, because value of a is not dependent on x. So if I had written it like limit of 5 times this thing, 5 times of sine 5x over 5x, this writing it like this and writing it like this as 5 times limit of this thing would be the same thing. So I can rewrite this as 5 times 1, and plugging in 0 for this x would become 1 over 0 plus 2. That would just become 1 over 2, and this thing would become 5 over 2. Okay. Now we've been told that this function is continuous at point 0. So the functional value of at point 0 would be the same as the limiting value of the function as x approaches 0 of fx. We know that the functional value of point 0 at point 0 is k plus half, and as limit approaches 0 of this function is, we just calculated that it becomes 5 over 2, and now we can subtract half from both sides. K plus, what is wrong with the lighting here? Sorry for the disturbance, the power just went off. Again, this can be rewritten as k plus half minus half equals 5 over 2 minus half. This and this cancel out each other, and we are left with k equals, this would become, I mean, this can definitely be done the easy way. 5 over 2 is 2.5, and this is just 0.5, so we'll just be left with 2. And the answer is k equals 2. Okay, now this can be done using the Euler's rule as well. The limiting value at as x approaches 0 of the function that can be solved using the illustrator rule as well. Limiting value of as x approaches 0 of f of x is limit of x tends to 0 of sine 5x over x square plus 2x. Using the illustrator rule, we are going to be taking the derivatives of both the denominator and the numerator. This will become 5 times cos 5x over 2x plus 2. Now we can definitely plug in 0 for x. This will become 5 times cos 0 over 2 times 0, 2 times 0 plus 2. So this will become 5 times 1 over 0 plus 2. So this just becomes 5 over 2. And we reached the same point. I told you that doing this using the illustrator rule is going to be very easy. I just showed you methods to solve this question in two different ways, because I believe that mathematics is not just about solving questions or something like that. You have to be able to visualize mathematics. You have to be able to find pathways inside of your mind of solving different problems. You should be able to find out how we are going to approach the solution by just looking at the problem. And how does that happen? Well, that happens by consistently practicing more questions and trying to solve the same question using different methods. That is gonna be really important. The previous one we did was using algebraic manipulation, and this one we did using the illustrator rule. Definitely learning both was important, because obviously either using either of them would get you the same number of marks in the exam hall. So considering that, you should only practice the shorter method. But if you want to develop your mind in such a way where you can think of pathways to solve different problems on your own, then you should definitely try to solve the same problem using different methods. That is the only possible way you will be able to look at a problem from all the different perspectives there can be. You can be a truly multi-dimensional thinker. I think that is uh, that is what really is the essence of mathematics. Anyway, enough with that. As always, if you guys think that you have any doubts regarding anything I have taught you guys today, you can definitely let me know about that in the comment section. I will try to resolve your doubts. Until then, keep learning. Goodbye.